This is video number 2. We are doing lesson 5-8 and this is page 356. Now I want to start by telling you that this lesson is so worthy of being done in its absolute completion. It is a great lesson and important material, but we are going to need to get the nuts and bolts of this lesson and not do all of it. The reason for that is that I want to be careful not to overload y'all with a test coming next week and a lot of material in a close proximity of time. And I want to focus on the foundation of this lesson. It will be important for us in moving forward. If we need to come back and go into more depth, we absolutely can. But anything that we are omitting in this lesson is simply building on the foundation. So I am making sure that you have the most important parts of it. We're just not doing all of the applications of it. So it's not that we're skipping material. We just are not building on it to the fullest extent. But what we're going to be talking about today is applying special right triangles. And it's really neat how these work. We're going to study two special right triangles. One is going to be the 45-45-90 triangle, and then we're going to study the 30-60-90 triangle. But let's start by reading at the top. A diagonal of a square divides it into two congruent isosceles right triangles. That means if we take a square and fold it in half at the corners, it's going to create two triangles. They're both going to be right triangles because we started with a square, and they're both going to be isosceles because the sides of that square were congruent to start with. Since the base angles of an isosceles triangle are congruent, the measure of each of those acute angles is always going to be 45 degrees. So another name for an isosceles right triangle is a 45-45-90 triangle. Now the triangles that we are dealing with today are all going to be right triangles. That must be a factor in this. So always make sure that you're dealing with a 90-degree triangle or a right triangle. So here's an example of what we were just talking about. When we take that square and cut it in half, we're left with two sides that are equal. We're left with a right triangle, and we've created two 45-degree angles. And the same would be true on the top half if it were folded behind it, or if it's unfolded. It's two triangles that are congruent with the same characteristics. A 45-45-90 triangle is one type of special right triangle. You can use the Pythagorean theorem to find a relationship among the side lengths of a 45-45-90 triangle. So let's look at that. Let's use the Pythagorean theorem on this bottom right triangle. So we have a squared plus b squared equals c squared. We have x squared plus x squared equals y squared, as you can see there. We add our two x squares, and that's 2x squared equals y squared. And then, because these are still squared, and because we can't solve for this simple y right here until we take the square root of it, we put a radical sign over both sides. The square root of y squared becomes y. The square root of 2x squared becomes x radical 2. Because this x squared was squared in the radical, it gets to come out of the radical and just be an x, but we could not simplify the 2. So what this is telling us on the bottom is that the hypotenuse, which is y in this case, is always going to be the leg. Do you see the leg right here? It's an x times radical 2. That's the special relationship that we're looking at in a 45-45-90 triangle. Excuse me. So again, in a 45-45-90 triangle, we're going to have two legs that are congruent because it's isosceles. And we're going to have a hypotenuse that is equal to a leg times radical 2. Let's look at how that plays out. Here's your theorem. Let's just read it. It's the same thing I just said. In a 45-45-90 triangle, both legs are congruent, and the length of the hypotenuse is the length of a leg times radical 2. Looking in my notebook, I've simplified that for you. The legs are the same length. That means leg equals leg. Here we go. Leg equals leg. We know by the isosceles theorem that if those two angles are congruent, then these two sides have to be congruent. So we already knew that that would be the case. And then the second qualification is the hypotenuse is a leg times radical 2. So in this 45, 45, 90 triangle, our hypotenuse is going to be a leg times radical 2. Now, we call it a 45, 45, 90 triangle because it has a 90-degree angle and two 45-degree angles. Okay, moving ahead, let's apply this theorem to do some problem solving. We want to solve for x in this problem. The first thing we need to ask ourselves is it a right triangle? Yes. Okay, so then we know that the second two angles have to be 90 degrees when put together. So we know this is going to be 45 because this is 45. We also know that they have to be congruent when we have an isosceles triangle or a 45, 45, 90 triangle. So since we knew that this was 90, 45, and 45, we now also know that if this side is 7, this side also must be 7 because the two sides opposite the two congruent angles must be the same. So we do have leg equals leg, but now we need to solve for the hypotenuse of this triangle. Well, solving for the hypotenuse in a 45, 45, 90 triangle simply means leg times radical 2, or in this case, 7 times radical 2, and there is nothing that we can do to simplify that. That is our final answer. Let's look at the next one. In this one, we're not told anything about the angles except that it's a 90-degree angle. I'm going to switch over to my pencil here. I would like for y'all to be able to differentiate between what was given already with purple and what I'm writing now. So the next thing we need to notice is that this is in fact an isosceles triangle because these two legs are the same. So that tells us that these corners are going to be congruent and they're going to be 45 degrees each because they have to add up to 90. Because 90 plus 90 equals 180, the inside of a triangle. All right, so we can use our 45, 45, 90 theorem to solve for our x's. Well, remember our relationship between a leg and the hypotenuse. The hypotenuse is going to be the leg times radical 2. So let's plug in what we have here. We have our hypotenuse, which is 3, and we have our leg, which is x, and x times radical 2, according to our formula right there, x times radical 2 should equal the hypotenuse. Now let's solve for what x is because we need to solve for the leg. So we are going to have to divide both sides by radical 2, and we're going to have x equals 3 radical 2. This is what we did in the preview to this lesson when I was working on dividing radicals with you. So now we cannot leave that way. We've got to get rid of the radical 2 on the bottom. So we have 3 radical 2, and we need to multiply by a radical 2 on the bottom to get rid of that radical 2. Whatever we do to the bottom, we must do to the top. So on the top, we're going to have 3 radical 2. On the bottom, we're going to have radical 4, which reduces to 2. So radical 2 times radical 2 is just 2. There's nothing that can be done to simplify here. So x is actually equal to 3 radical 2 over 2. That would be our length here, 3 radical 2 over 2, and our length here, 3 radical 2 over 2. Okay, let's look at one more. It is this triangle, and it is 3, x, and x, and we are told that it's a right angle. Okay, once again, we see that it's isosceles. You know what, y'all? I am about to repeat the same problem that we just did. I apologize. Let me cross through that. I'm sure you probably realized that before I did. Let's draw a different triangle. Okay, this one will be 10 radical 2, and we're given an x down here, and we are told that this is congruent to this and that this is a right triangle. So let's solve. We need to solve for x. Well, we know that since these two angles are congruent and since this is a right triangle, that we have a 45, 45, 90 triangle. Therefore, we're going to apply our 45, 45, 90 triangle theorem. Well, we know that because those angles are congruent, these sides are also congruent. So if this side is 10 radical 2, then this side is also 10 radical 2. But what we really need to solve for is our hypotenuse. Well, remember, our hypotenuse equals a leg times radical 2. So we're solving for the hypotenuse, which is x. I'm just going to keep it as h for the moment to represent hypotenuse, but it's our x. And hypotenuse is going to equal a leg, which is 10 radical 2. So 10 radical 2 times, remember it was leg, and that's the 10 radical 2, times radical 2. So now we've got to multiply that by radical 2. Well, when we have this, that's going to be 10, and it's going to be radical 2 times 2 within the radical sign. That is radical 4, so we have 10 radical 4, which equals, we can take a 2 out of this because the square root of 4 is a 2, so we're just going to have a 10 times a 2 with no radicals, and that is going to be 20. So our hypotenuse of this triangle is going to be 20. Remember, you can stop, pause, go back, do whatever you need to do to cement this, but I'm going to do one more with you because I want to make sure that I'm giving you the tools to be on top of this and to do this homework well. So this one, sorry, this video is ending up longer than I had anticipated. Y'all probably aren't surprised by that. This is what we're given in this triangle. 45, 45, 90. This leg is x, the hypotenuse is 16, and this leg is going to have to be x as well because this is an isosceles triangle. All right, we need to solve for the legs. Well, remember, we know that a leg times radical 2 is equal to the hypotenuse. We need that formula because we're given the hypotenuse. So hypotenuse equals leg radical 2. We need that to solve for x. So in this case, it's x radical 2 because the leg is x in this problem. So x radical 2 equals the hypotenuse, which is 16. To get x alone, we must say 16 divided by radical 2. From there, we need to simplify. We cannot have that radical on the bottom, so you see what I'm doing to get rid of that. That's going to produce 16 radical 2. And then on the bottom, we have radical 2 times radical 2, which is radical 4. The square root of 4 is simply a 2. This is not a final answer because it must be reduced. 16 divided by 2 is 8. So our final answer is 8 radical 2. That is the length of our legs. And I'm looking to make sure that's correct. Yes, it is. And I'm going to put it right there so you can see the whole problem. Pause it, study it for a minute, do what you need to do. That's the end of that video. And we will move on to the other type of special triangle, and that's our last job.